Oh, can you hit the lights? Oops. All right, so you have three states. In order to get a nerve impulse to happen, you start with a polarized state, move on to depolarized, and then you repolarize or set back to original. So what I'm going to do is I'm just going to label that as step 1, 2, and 3 really quick. We're just going to put a 1 here, a 2, and a 3. And what we're going to do is we're going to graph these changes on a graph that shows the membrane potential of a neuron over time. So on my paper, I have a little bit of space on the right side, so I'm just going to use that. If you have more space somewhere else, feel free to do it wherever you want. Actually, maybe I'll do it at the bottom. All right, so this is membrane potential over time, so we're going to draw the y-axis here. What? Yeah, there's this desk over here behind Allie. So here's my y-axis. This will be where we graph the membrane potential. With the units millivolts. Membrane potential with the units of millivolts. And our x-axis would be time. So we start the neuron at approximately negative 70 millivolts. So I'm just going to write negative 70 down here. At some point, its maximum is at positive 40 millivolts. So I'm going to write positive 40 at the top. So at polarized state, you have a neuron about right here, hanging out, just chilling, nothing's happening. And then somebody taps you with a pencil. When that change in pressure of your skin occurs, sodium starts entering the neuron and it starts getting more and more positive. And you have to get enough sodium in beyond negative 55 millivolts. If you don't get enough sodium to bring it to negative 55, it will not, the nerve impulse will not happen. Okay?
You wouldn't feel it?
You wouldn't feel it, which is totally possible. Have you ever tried like tapping on somebody like to pass out your paper and then they just either ignore you or they just don't feel it and you're just like, that's awkward. Or like when somebody else is tapping on you and you're like, how long have you been, yeah, anyways, okay. Well, sometimes if you don't get past that threshold, your brain will not pick up that signal. Okay? So once you pass 55 though, it'll continue to add sodium to negative or positive 40. And then once you're at positive 40, the neurotransmitter release, and so potassium will start flowing out. Sometimes it flows too far out and you go beyond negative 70.
Wait, is positive 40 like max?
Yes.
Wait, so like if you got hit with something else, it would just be the same thing? Like
Yes.
If you got shot?
Yes. So if you get a stimulus beyond negative 55, which let me note that as the threshold really quick. So someone tapping you with a pencil versus you getting shot, your neurons will fire to max 40, and that is it. So why does one kind of hurt more than the other? Usually.
Is it how quick you feel?
It has to do with the speed of the nerve impulse. So for example, you notice we only drew one peak right here. If you were tapped with a pencil, you might feel just one peak like that. Your brain would say, I just got tapped with a pencil or something. If you were to get stabbed or shot, your graph would be about as high, except you would see faster or more oscillation. So you would have higher frequency of a graph. Okay? So that's what would register as pain. So the more of these nerve impulses you have, the more of a stimulus you would feel. Okay? So I do want to note something. The idea of passing this threshold is known as the all or nothing principle. Kind of like with muscles, once muscles get a high enough stimulus, they will contract all the way. If it's not a good enough stimulus, it will not contract. For neurons, same thing. If you do not get beyond 55, negative 55, you will not be able to go all the way to 40. You will not feel anything. So that means once the threshold is reached, then the nerve impulse occurs. And it will occur at maximum strength. It will go all the way to positive 40 regardless of what the stimulus was. If you have a stronger stimulus, such as a stabbing or a slap or a punch, these nerve impulses will just happen faster.
Does that say E max? Or
At max. At maximum strength.
How does it work for hearing?
We're actually going to do ear later this week. Yeah, so we'll get to that. All right. So let's go ahead and take a stretch break really quick. Get up, walk around, stretch, go to the bathroom if you need to.
Are we stopping at that little thing at the end? We're started, but didn't hit negative 55.
Uh-huh.
I should have to pee.
For the graph?
Yeah.
Yeah, that's it. Yeah. So we're actually going to talk about nerve adaptation when we come back, hopefully.
Because I didn't sew the feet right, so they got inside.
I would have been so good if we would have done
It's okay. It's cute.
I know.
All right. So just to recap, you get some sort of stimulus. Sodium enters, sodium enters, potassium leaves, potassium leaves, potassium leaves. On your graph, we're going to do a little bit of a key here. So right here, where you have nothing happening, that's stage 1 of polarization. So where would stage 2 be? The increase of sodium, influx of sodium. Where would stage 2 be? Uh-huh. And a little bit more than just the threshold, just more than just this area, right? It's the whole, yeah. It would be the whole thing right here. That whole increase would be a depolarization. So where would number 3 be? The whole way down. As potassium leaves, more and more positive leaves, so you become more and more negative. So all of this would be number 3. And then I wanted to note something else. At this point right here, do you have any more sodium coming in? No. So you have sodium channels are closing. What's leaving? Potassium, which means you have to open up your potassium channels. So potassium channel opens, sodium channels close. And then once the sodium, potassium exchange hits the very end, the axon terminals, you get a release of neurotransmitters. Those neurotransmitters travel across the synaptic cleft, bind to the receptors, and then it'll tell this next neuron or nerve or muscle or organ to do something, okay? But how does that all start? If we think of an example like that lab that we've done, lab 4.1, the only lab we've done, actually. So remember that lab where I made you taste a whole bunch of different stuff and it was really fun and you loved it? Yes, thank you. So that lab was fun. It wasn't just so that I could watch you guys and it was just for giggles or anything. But one way that you can get neurons to start firing is like the neurons in your tongue, in your taste buds. You have these neurons that are sensitive to certain chemicals. For example, you have, let's see, a lot very sensitive neurons at the tip of your tongue for salty flavors. And then in the back of your tongue, you have a lot of very sensitive neurons for bitter tastes. And it looks like the middle of your tongue doesn't really have much of any neuron. Okay? So once you put that onto your partner's tongue, the sodium binds right onto the neuron starts firing right away. And it sends that message to your brain, this is salty, this is really salty. Okay? So there's that. But I want you guys to think about how is it possible then if you have these neurons on your tongue, and a lot of you tasted the bitter one, and some of you were just like, it's just strong everywhere. I can just taste it so badly everywhere. But some of you were just like, not phased. Don't really taste anything. Nothing. As you can see, some people just like none all the way across. Did not taste the coffee. It was coffee, by the way, if you couldn't figure that one out. It's the black liquid. So I have a question for you guys. Typically, as you get older, your taste buds, for some reason, you're able to drink more bitter things, or you're able to eat more bitter things. Now the question is, why does it have to correlate with age? What does your taste buds have to do with age? So if you want to just take a minute and discuss this with your partner, the question is, why do you think adults are more tolerant to bitter flavors? All right, does anybody want to take a guess as to why adults are more tolerant about bitter things like dark chocolate, 90% cocoa chocolate, yum, and just black coffee, aside from cost reasons, of course. Any guesses as to why old people are awesome? No? Yeah?
Oh, never mind.
What?
I don't know. Maybe they lost their taste buds and now their tongues and they can't really.
Maybe they've lost their taste buds, yeah.
Since like bitter's like the easiest, like the most tolerable to taste in the first place, and like as like time goes on, like they drink it more, their like taste buds become more like can tolerate it more.
Okay. So, yeah, Grayson?
Because you can taste the bitter stuff easier, and through time when you lose it, they can still kind of taste that more than other stuff.
Okay. So it does kind of have to do with loss of taste buds. How do you lose taste buds? You've probably done it a couple of times before.
Like you drink something really, really hot and just go to
Yeah, you know that one time where you were like, ooh, hot cocoa, and then you drank it, and it was really, really, really hot, and then it really hurt, and then you couldn't taste anything for a couple hours afterwards? You just killed a couple hundred taste buds. Okay? But the awesome thing is it's like hair. It'll grow back. However, like hair, as you get older, it grows back slower and slower and less and less. And so if you don't have the neurons that are triggered by bitter, you're able to eat and drink bitter things and they taste fine to you. Okay? Yeah.
I just feel like I'm really hungry now.
What?
Your taste buds improve. Like if you're really hungry, your taste buds improve.
Oh, because you're like, oh, this tastes so much better when you're
Yeah.
hungry, right? That's an interesting question. So, because if you've ever eaten at a restaurant when you were really hungry and you're like, oh yeah, this is like the best restaurant ever, and then you came back when you weren't so hungry and it was like, eh.
So you think like your brain sends signals maybe
Maybe it has to do, yeah, it has to do with like the need for it, right? Your body will say, yeah, you need more food.
like a drink that you're really
It's probably just a mental thing. Okay, dehydration. Sorry, you guys can go ahead and pack up. When your mouth is dry, it does mess with your taste. Yeah, that's That's why older people, their mouths are drier and it's harder for them to taste food, along with not having as many taste buds. I still have 3 minutes, by the way. Alright, so I made some more awesome graphs and charts for you guys. I know it's a little blurry, but part B of the lab, where you ate food without smelling and then you ate food while or right after smelling it, notice that if you weren't able to smell it, more people were likely to miss what the food item was. And then when you were allowed to smell it first, more people were able to correctly guess. So what's happening here is the neurons from your tongue and the neurons that are attached to your nose, they help each other. They tell your brain, hey, I smell apple, and your tongue is like, yeah, it does taste sweet. Your brain will be like, okay, this is probably apples, okay? But there are times, you have different senses, by the way. You also have sight and hearing and balance and touch, right? There are times when your signals will get mixed up, and one sense will tell the brain this, and the other sense will tell the brain that, and then your brain gets confused, and then you get nauseous, and then it's just all bad. So I want you to just take like 15 seconds, talk to your partner. When do you get mixed signals coming from different parts of your body?
I'm so confused on the question.
Maybe when you're speaking to you never let them have you.
Well,
Wait, I heard someone say it. Lance. Car sickness, because your body is telling you that you're moving, but if you're reading a book or you're staring at your phone, what are your eyes saying? Your eyes are like, nothing's happening. Just reading a book right now, we're not moving. And then your brain's like, which one is it? And then it's just like, I give up, and then you just get really nauseous and sick and sad. Right? Just mostly sad. Or what about, does anybody get seasick? All right, that's the bell. Okay, goodbye. I think so. I don't know.
That does sound